Hello once again and welcome to today's lesson. So today we are going to cover learning outcome 6.07 and it is another transformation. This time it is reflection. Okay, yesterday we did translation, today we are going reflection, and tomorrow we are going to cover rotations. So what is a reflection? Okay, a reflection is like when you look at a mirror. Okay, when you look at a mirror, you see yourself on the other side of the mirror. So reflection is a transformation where each point in a shape appears at an equal distance on the opposite side of a given line. This line is called the line of reflection. So if, for example, I have the line of reflection, which is the pencil. Okay, so the pencil is the line of reflection. I have an object which is on this side. Okay, the image will appear on the other side, so on this side. Okay, it will appear on this side, and the distance from the object to the mirror will be equal to the distance from the line of reflection to the image. Okay, like when you look at a mirror. Okay, when you look at the mirror, if you're 60 centimeters away from the mirror, you will see your image 60 centimeters away from the mirror. Okay, so I'm going to cover this learning outcome by following a PowerPoint presentation. As I told you yesterday, there's no need to print these notes. Okay, I'm going to leave your homework as a separate document. So let's continue here. Okay, on the PowerPoint presentation. So as I told you, we're going to cover reflections today. Okay, but before covering reflections, let's do some revision on vertical and horizontal lines. Okay, those lines that we did in the topic of straight line graphs. So name the line. Remember that vertical lines are x is equal to something. Okay, x is equal to something, while horizontal lines are y is equal to something. Of course, that something is a number. So either x is equal, for example, to 5, y is equal to 2, etc. Now, what about this line? This line passes from, remember that here we have x, and over here, of course, we have y. So here x is equal to 5. So this line is x is equal to 5. Okay? Let's take another line. So over here, we have this line. Here is 0 on the x-axis. So this must be minus 1. Okay? So on the x, it is minus 1. So this line is x is equal to minus 1, as you can see here. Another line, this time a horizontal line. So a horizontal line must be y is equal to something. Since it passes from y is equal to 6, this line is called y is equal to 6. This line, again, it passes from y is equal to 1, so the line is y is equal to 1. Then now is revision. So this is a new line. Okay, this line is called y is equal to x. Why it is called y is equal to x? So basically it's very simple. Let me explain why. So when x is 1, here is 1. Okay, so if we draw these lines here, okay, when x is 1, so when x is equal to 1, y is equal to 1 as well, as you can see here. When x is equal to 5, y is equal to 5. Okay, so when x is equal to 5, y is equal to 5. So that's why it is called y is equal to x, because the values of x and y at any given point on this line are equal. So that's why it is called y is equal to x. Let's see another line. So this line, this line is going to the left, okay? It's going to the left. Of course, this line continues. So if we take some points on this line, we can see that this line here is equal to -1. So when x is equal to -1, y is equal to y is equal to 1. When x is equal to 2, sorry, here I must write -1. Okay, so when x is equal to -1, y is equal to 1. When x is equal to 2, y is equal to, if we read the value over here, here is -1 and here is -2. So y in this case is -2. So you can see that whenever one value is positive, the other value is negative. Okay? So this is positive, so the other one is negative. This is positive, the other one is negative. So this line is called y is equal to -x. Okay? Y is equal to -x. Because when y is equal to 1, x is equal to -1. You can see that? Okay? When x is equal to 2, y is equal to -2. So we have changed the sign. Okay? So that is why this line is called y is equal to -x. So that's some revision of what we have already done. So, but today's lesson is about reflecting shapes in a given mirror line. So let's take this triangle. Reflect this triangle in the line x is equal to 5. So this red line over here is the mirror line, okay, where we are going to put the mirror, okay. Of course, this line in maths is called the line of reflection. So what we have to do is, first of all, we must know where the shape, the image is going to be. So if the mirror is over here and we have this triangle here, okay, this triangle is called the object, okay. So if the object is here, the triangle is here, where I am going to find its reflection? Are we going to expect a reflection here, on to the left? Are we going to expect a reflection here or to the right? Of course, since the line of reflection is here, we're going to expect the image somewhere here. The reflection is going to be over here. Okay, now how do we find the new points? So to find the new points is very easy, as I told you before. So let's start from this point over here. This point is one box away from the line of symmetry. So this point in the reflection must be as well one square away from the line of reflection. Sorry, first I said line of reflection. Okay, this is the line of reflection. Let's take another point. For example, this point is 2 squares away from the line of reflection. So from the line of reflection, I'm going to count 2 boxes. So 1, 2. To find this new point, this point is 2 boxes away as well from the line of reflection. So from the line of reflection, I'm going to count 2 boxes as well. And here we have the three sides that that forms this triangle. Okay, so this is the reflection of this triangle. Okay, let's take some more examples. Here you can see it correctly drawn. We need to reflect this rectangle in the line x is equal to 1. So x is equal to 1 is already given, this red line, okay, and we have this rectangle. So 2 points, these 2 points are on the line of reflection. Now, when you touch a mirror, okay, if you touch a mirror with your finger, you can see your image of your finger touching your finger. So here it's the same. If we have these 2 points on the line of reflection, they will remain in the same place, okay? So these 2 points will remain in the same place. Now, what about the other 2? Let's begin from this point. This point is 2 boxes away from the line of reflection. So we must draw this point 2 boxes away. This point over here, it is 2 boxes away from the line of reflection. So again, 2 boxes from the line of reflection. And there we have this rectangle over here. Okay? You can see it perfectly here. Now we have this hexagon, and we need to reflect this hexagon in the line x is equal to 4. Again, x is equal to 4 is given, okay, there's this red line, and we must do what we have done so far, okay? So this point is 1 box away, so 1 box away from the line of reflection, which is here. Always, as you can see, always perpendicular to the line of reflection. When I say perpendicular, is that between these 2 lines we have a 90 degrees over here, okay? To find this point, so this point is 2 boxes away from the line of reflection. So again, 2 boxes away. So we have to draw that point over there. We have this point 2 boxes away from the line of reflection. Always start from the line of reflection. So there we go. Another one, which is over here. Another one, just 3 boxes away, and this one is 4 boxes away. So 4 boxes away. And then we can draw using a ruler and a pencil, okay, we can draw that reflection over there, okay, as you can see here. Now, when we have the line y is equal to 2, y is equal to 2 is, we have, this is the y-axis, okay, and this is the x-axis. So this blue line is y is equal to 2. As you can see, it is passing from y is equal to 2. Now, to reflect this rectangle, all we need to do is, this time we're going to count vertically, okay? So this point is 1 box away from this line of reflection, okay? So from this line of reflection, we're going to count 1 box. So this point is now this new point. This point here is 1 box away, so again 1 box away. This point is 2 boxes away from the line of reflection. So 2 boxes away from the line of reflection is here. And this point, 2 boxes again, and that is the rectangle joint. Okay, that is the rectangle. Another one. So reflect this trapezium in the line y is equal to 1. Again, we have this line y is equal to 1, and we have 2 points, 2 points which are on the line of reflection. Okay, so since those 2 points are on the line of reflection, they will remain where they are, exactly where they are. We need to find these 2 new points. So this point is 2 boxes away, so 2 boxes away from the line of reflection, which is here. Again, this point is 2 boxes away, so 2 boxes away. And then we need to join the points, and that's it. Okay, so that's the reflection. Now, as we have seen before, this line is called y is equal to x, and the other line is called y is equal to minus x. And now we're going to reflect in these lines. So we need to reflect this trapezium in the line y is equal to x. So we have this trapezium over here, we have this line here, and we need to reflect this trapezium in this line. We know that the image is going to be somewhere here on this side, okay? So at least we have that idea that where the image is coming. But to do that and to do it accurately, we have a small trick. What we have to do is to write all these coordinates of the vertices. Okay, so for example, the first point, which is here, we have 1 on the x and 0 on the y, so 1, 0. This point over here is 5, 0, 5, 0. This point over here is 2 on the x and minus 2 on the y, so 2, minus 2. This one here is 4 on the x-axis and minus 2 on the y-axis, and minus 2 on the y. What we have to do is we need to change the position of the x and y coordinates. So if this coordinate is 1, 0, now we're going to write 0, 0, 1. Well, let me write it here, 0, 1. Okay, so we just changed their position. Okay, that's all that we're doing, and we are finding the new coordinates of the reflected image. The next one is 0, 5. Okay, next one we have 2, minus 2, so change their position, so minus 2, 2. The last one, 4, minus 2, change their position. So these are the points that we need to plot in order to find the reflected image. So 0, 1, 0, 1, which is here, 0, 5, which is here, minus 2, 2, so minus 2, 2, minus 2, 4, minus 2, 4 over here. And that is the reflected image over there. Okay? And here you can see it properly as well. Okay, let's take another example. So this one, we have reflect this triangle in the line y is equal to minus x. So again, we have a trick to do this. Okay, first of all, the line y is equal to minus x is this line, okay, which passes from minus 1, 1, minus 2, 2, minus 3, 3, etc. Okay, and I'm going to write again the coordinates of this triangle. So let me start from this one over here. It is minus 2, 4. So minus 2, 4, the first one. I'm going to take this one, so it is minus 2, 2, minus 2, 2, and the third one is this one, so minus 1, 2. It doesn't matter the order that you take them. Okay, you can start from here and continue, it doesn't matter. So what we're going to do here is that, as we did in the line y is equal to x, we are going to change their place as well. Okay, we are going to change their place. So instead of minus 2, 4, we're going to write 4, minus 2. So this comes first, 4. But not only, we are also going to change their sign. So this 4 is positive. So I'm going to write 4 here, but it will become a negative 4. Okay, this is very important. So when we have the line y is equal to minus x, since we have that minus over there, okay, it changes also the sign. So we are going to change their position, okay, change their position together with their sign. So 4, which is positive, will become minus 4. We have minus 2 here, so comma 2, because we have changed it from minus, negative to positive. Here, again, we're going to change their position and change their sign. So we have 2 here, okay, so it will become minus 2. We have minus 2 here, so it will be 2. As you can see, it remained the same. Can you tell me why, maybe? Of course, I cannot hear you, but it's because this point is on the line of reflection. So as we did before, this point will still be where it is. It won't change at all. Okay, so that's why these are the same. Next one, we have minus 1, 2. So change their position and change their sign. So we have 2, which was positive, so now it is negative, and we have -1, so it will become 1. So -2, 1. And we need to plot these points to get the reflected image. Of course, it will be somewhere on this side. Okay, so -4, 2. So -4, 2, which is here. Okay, which is this point over here. Okay, -2, 2, which is already in place, and -2, 1. -2, 1 is this one, and this is the triangle, the reflected triangle. Okay, as you can see here we have also these lines which are also parallel, not parallel, sorry, perpendicular to the line of reflection. Okay, look, these lines are also parallel to the lines of reflection. Okay, so here you have it as well, the reflection. Now let's also cover this question. So this question is reflect the triangle in the y-axis. So the y-axis is this is the y-axis. Then reflect that triangle, okay, so the one that we're going to draw, in the line y is equal to x. So let's start by reflecting this triangle in the y-axis. So the line of reflection this time is on the y-axis. So this is the line of reflection, the green line. Okay, so these 2 points are already on the line of reflection. We have only this point which is not, so that point will be here. So the triangle is here. Okay, then he asked us as well to reflect that triangle, this green triangle now, in the line y is equal to x. The line y is equal to x is this line. Okay, is this line. So as we did before, we can write the coordinates of that triangle. Okay, we can write the coordinates. Let's start from this one on top, which is 0, 2, 0, 2. This point is 0, 0, and it will remain where it is because it is on the line of reflection. And then we have this line which is -1, 0. So since the line is y equal to x, we only need to change their position, not their sign. Okay, so 2, 0, this will remain the same, and 0, -1. So let's plot that. So 2 on the x and 0 on the y, which is there, 0, 0 over here, and 0, -1, which is here. And this is the reflected triangle of the green triangle. Okay, as you can see, as before, we have also these lines which are perpendicular to the line of symmetry. Okay, so this is the reflection, and then the reflection in the line y is equal to x, which is that triangle. Now we need also, as we did with translation, we need also to describe reflections. Okay, so we need to identify that it is a reflection, and also that the line. Okay, we need to write the line. So draw and name the mirror line. So over here, draw in the mirror line and describe the reflection. So as you can see, this is not a translation as we did yesterday, because a translation will leave the triangle facing the same direction. So if I had to move this triangle around, it will still have this side facing to the top left. Okay, not like here. This one is this side is facing top right. Okay, while this one is facing top left. So it is a reflection, of course, and the line of symmetry is somewhere here. Okay, to decide where the line of reflection is, it's very simple. All we need to do is count the space between the two triangles. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8. So in between it is 1, 2, 3, 4. So the line of reflection is this line which passes from x is equal to 1. So it is a reflection in the line x is equal to 1. Okay, that is how we describe a transformation which is a reflection. Okay, reflection in the line, and we must write the line x is equal to 1. So as you can see, that is the line of reflection, and it is reflection in the line x is equal to 1. Of course, this is another reflection, and this time the line of reflection is over here because we have two boxes. Okay, two boxes here, so it must be in the middle. Again, that is the line of reflection, and to fully describe the transformation, we must write reflection in the line y is equal to 2. Of course, this is y is equal to 2 because it passes from the y-axis where y is equal to 2. So that's all for today. So today we have covered reflections. We have seen how to do a reflection, okay, and also how to describe a reflection. Okay, I will upload you the your homework as well. Okay, so that's all for today. Hope that you understood this lesson. I will see you tomorrow for rotations. Bye for now.